revive the name. Where the series went dormant for a bit, we revived it, and now that it's back up, we'll continue for a while. We had the first science Adda when we moved into this facility with Salman. The very day we moved in, so it's opportune that we revive it again, once again with Salman. We started the science Adda in 2007, Sabine, myself, and Zahir Saab. The idea was to enhance public engagement with science and to do it decidedly out of an ivory tower setting, to sort of extricate science of the smoothiness that accompanies it often. And since we've had a number of events, Dr. Pradesh Boy, the chairperson of the initiative, has done 22 science Addas. Salman, I think, has done the most science Addas with us. His fifth talk here, backed by popular demand. Salman is Charles Taylor Chair and Associate Professor of Integrated Science and Humanities in School of Cognitive Sciences at Hampshire College. He's also an astronomer. I almost called you the Charles Simoni Chair, which you're obviously not. So a few years ago, Salman started the online extension of the Science Adda, and he's done 14 videos now, which is doing extremely well online. It used to be called Science Adda Plus, but I guess some slip of the pen made it also Science Adda. But I guess they're different manifestations of the same underlying reality, which is to enhance public engagement with science, increase public awareness of science. So thank you all once again, and hand it over to Salman. The talk is on extraterrestrial intelligence, and so it will really suck if your terrestrial devices ring in between. गुजारिश ये है कि मोबाइल फोन अपने बंद कर दें. Over to you, sir. The talk will go on for an hour. उसके बाद we'll have Q&A, which will also last for about an hour. Over to you, sir. Thank you.
So, what did you decide to do? Make English? Mix. So, I will start with English. और वैसे मुझे interrupt आप करें, आप सवाल जो आपके हैं वो उर्दू में और मैं दोनों जाता हूँ, तो मसले की बात नहीं. So before I start, I do have to acknowledge that, as Zaki said, we started it with Sabine. The Science Adda, by the way, online one also was actually Sabine's idea, and it's the first time I'm coming back and Sabine is here right now with us. And so, I mean, it's both. So it's both sort of like a delight to come back at T2F, because this is my favorite place on the planet. I mean, I've always come back, and I'm on the record saying that. So I'm not just, I don't go to every place and say, this is my favorite place. It's not like I'm going to a concert, like, hey, hello, Karachi. No, it's not like that. I actually do mean it. And so next time if I say it someplace else, you can actually get, no, actually your place was T2F. And I've always said that. It's actually quite incredible. And so the reason why I've done so many Science Adda is not because of popular demand, but it's because I always come back and say, can I give a talk here at T2F? And so it's both a pleasure to be back. It's 5 years, but also moving. So right now, so I will try to move on from there. Okay, so, but let's go to the talk first. Okay, so what we'll start doing is I'll start posing this question about extraterrestrials. We have seen images of extraterrestrials in movies. Some people have claimed to have seen extraterrestrials out in the sky. By the way, I had the remote. What did I do with that? Okay. Great, thank you. So, so people have claimed to have seen UFOs in the sky, which people claimed it's unidentified flying objects, but people have claimed that those are actually spacecraft being driven by alien intelligences. Okay. There are claims of alien autopsies. There are claims of alien abductions. So there is a whole slew of claims about extraterrestrials. So when we say intelligent life in the universe, to a certain degree, people have an idea that there might be out there because they have seen it or they have heard it or they believe it or they are skeptical about it, but you don't have to actually think too much about it. But what I want to do today is to actually lead you through partly the first part into a historical look at how the idea of extraterrestrials became scientific. Because one of the questions comes in as an astronomer, actually we do get this question, so are there aliens out there? Okay, well, the answer is actually tricky, how to answer that question. And so how do we think about it, and how have historically us as humans have thought about this question and what are the implications? So that's what I'm going to do. But I will start with this disclaimer slide that as of today, right now, this is the only place in the universe, this blue spaceship you can think of. Okay, you see water, you see land. This is the only place in the universe where we know there is biology. There's a lot of chemistry out there. There are a lot of elements that make up life, like amino acids. There are complex molecules out there that make up life, sure. But biology, out of the entire universe so far, this is the only place we know of. So you have to keep this perspective in mind, that we are going with a sample of one in the universe. Okay. Now, I also want to add, but we have been thinking about extraterrestrials. And it is important that when we think about extraterrestrials, and part of the thing what I want to say about it, what does it say about ourselves? So, we are used to Hollywood, we are used to including, there are some Bollywood science fiction, and there are some, at least one, and at least there is one Lollywood science fiction as well. Was it Shan? No, was it? No. No, but that was, anyway, maybe not. But if you are thinking of making a movie, you have a good place to start. I think Lollywood, if you are listening, aliens. Okay, so, but the idea has been around for a long time. And so I want to take you back about 5th century BC and 4th century BC. So amongst the Greeks, there was this conversation about extraterrestrials, or at least about the idea of other worlds. So on this side here, there were this group of people who were called the atomists. Atomists believed that the world intrinsically, the universe intrinsically, is made up of small particles that are indivisible, and which they called atoms. Our term for what we defined, we as scientists defined atom, was in honor of the atomists. Although, of course, we know that atom is divisible, because the one that we know of, because it has a nucleus, it has protons, neutrons, and it also have quarks, and so on and so forth. But for the atomists, the entire universe is made up of these, fundamentally it's made up of these point-like things. And the key thing here is, they also believed that there are an infinite number of these atoms. Okay, now, if you have an infinite number of atoms, you have an infinite number of possibilities to form things out there. So the logical conclusion they made, so the conclusion, so this is the key thing. The conclusions from their cosmology was that everything is made up of atoms, infinite number of atoms. And from that implied, there must be other worlds out there, because the universe is infinite. From the possibilities, why not? If there is Earth, there might be other worlds out there as well. Competing idea was that of Aristotle. Aristotle believed that Earth is right at the center, and everything revolves around it, including, of course, the sun, and all the planets and all the stars. And that is the key component that, and you can see it, things moving around it. But it wasn't just that. In his idea, in Aristotle's idea, it also explained how objects move. So for example, if I drop this remote, I'm not going to do that, but if I drop this remote, it's going to go down. And it's going to fall because it's made up of material that is like Earth, solid. And so it's attracted towards the Earth, it goes down. If you have water, it also falls down, just like we saw today. Rain, so jab barish hoti hai, it falls down because water likes to go to its natural state, which is above the ground but still down below. And then you have fire, and then you have, you have air, and then you have fire. No, fire, then you have air, one of those two. So, but here was the key thing. If it explains motion of why objects move, then there must just be one Earth. Let's imagine another world out there. Where will the object fall to? Will it go over there or will it go over there? So Aristotle answered these guys by saying, you must be crazy. Because if there are more than one world, there will be utter chaos. And so Aristotle's idea was that no, there is one world, and Earth is at the center, and that implies there are no other aliens or there are no other worlds out there. Okay, so you see, so it is the cosmology, or what we would call their philosophy, deriving whether there is a possibility of extraterrestrials out there or not. Okay. Now, there is no science in it. They are not thinking in terms of scientific. So I am going to come to that of how this idea became scientific. Now, there have other people who have commented on that, whether they agree or not. This is Fakhruddin Al-Razi, this is not the Al-Razi, the physician. This is actually a theologian who wrote in the 12th and 13th century. He was commenting on Aristotle's ideas, which became more acceptable, which became more common, both in the Christian world and in the Islamic world. Nevertheless, for example, he commented, it has been proven by evidence that God the Exalted is capable of actualizing all possibilities. Thus, He be exalted is capable of creating thousands and thousands of worlds beyond this world, each of which would be greater and more massive than this world, and the argument of the philosophers for the uniqueness of this world is weak and poor, being based on invalid premises. Okay. So here is a case where he's actually going against Aristotle, saying, no, there is no uniqueness. But if you remove uniqueness, you have to explain how bodies move, and that is still a problem. Okay. But there are, as far as we know, there are not many Muslim commentators that actually talked about, medieval Muslim commentators that talked about the possibility of other worlds and extraterrestrials. But this is certainly one of the key cases. Now, in the Christian world, St. Thomas Aquinas, so he's in the 13th century. He is credited for bringing Aristotle centrally to Christianity. He was asked this question. So again, remember, this question of extraterrestrials is not a new question. He was asked this question, are there other beings out there and are there other worlds out there? So at that time you would say other worlds, and that would imply beings as well. Now, Aquinas was a major Aristotelian. In fact, actually, he used the work of Ibn Rushd. He actually used a lot of the work of Ibn Rushd, who also was an Aristotelian, so he brought it in. And from this logic, he actually said, no, there are no other worlds out there. Now, 13th century, the church at that time, the Catholic Church, said, wait a minute. At that time, he wasn't saint. He was just Thomas Aquinas. Okay. So the church said, wait a minute. You cannot say that there are no other worlds out there. Because if God wants to create other worlds out there, He would. How can you step on the providence of God? And in fact, the church placed this idea that there are no other worlds out there as a banned idea. And they went even one step further. They said not only God can create other worlds out there, but God did create other worlds out there. Okay. So here is this interesting case that because of Thomas Aquinas, actually the idea that there are other beings out there became an official doctrine of the Catholic Church. They said, of course there are other beings out there. Okay, now there is a slight problem with that, especially within the Christian doctrine. Because within that, Jesus, from that perspective, He came in to save all of humanity. So then the theological question arose that, wait a minute, if there are other beings out there, then how do we explain the sacrifice of Jesus? And so one answer was, well, there is Jesus on every other world, or his sacrifice on earth can cover everybody. Okay, now, I saw some people were sort of like, it's like, well, that's sort of like, however you want to think about it, that's problematic. Well, Thomas Paine, who wrote The Age of Reason, he picked up, he's a critic of Christianity as well, he picked up on this particular idea, and he said, look, Christians have to pick. Either there are no extraterrestrials out there, or you cannot have what they called a planet-hopping Jesus. They said, you cannot have Jesus sacrificing in every other world. And he said, this is just a faulty idea of Christianity. But he used extraterrestrials to criticize Christianity. Okay? But on the other hand, and now we are in the 19th century. So this is in the 19th century. This is Thomas Dick, who was also a theologian. He believed that there are 22 trillion, and he gave a very specific number, inhabitants just in our own solar system. Why? Because he also said that this was showing the glory of God. He believed, and at that time actually most people believed, that if there are worlds out there, and by that time people knew, of course, about planets. Planets people knew beforehand also, but there were other planets being discovered. And the idea was that if there are worlds out there, they must have inhabitants. Why would there be a world out there without inhabitants? So even if you have a moon, there would be beings out there because there is a moon out there. What's the point of having the moon? Mars. So Thomas Dick actually believed that there were, he gave very specific numbers like, that 10 trillion 503 inhabitants on the rings of Saturn. Okay, and he also believed they were also on Saturn, they were also on Mercury, they were also on Venus, and he gave all these numbers, he calculated them, and he came up with that there are 22 trillion inhabitants just in our own solar system, not to mention about the other ones. Okay. Now, one thing common so far in all of the things that I've said so far is they're all philosophical, religious / theological thinking about it. But they were still thinking. That question is not a new question. People are still thinking, well, and what does it mean for us? I mean, these questions get tied into that. But two developments changed this thing. And so this is the pivot. This is the key point for this talk. So if you leave after this, this is something that you should know, and then you can leave. There were two developments. One was the development of spectroscopy. So spectroscopy was developed in the mid-19th century. Spectroscopy is basically just a prism. Basically, when you take, and Newton did that, you take the prism and the light divides up into different colors. Now, in the mid-19th century, people started putting these prisms, in some sense, behind telescopes. And you can look for lines of elements. So you can figure out, so if you look at the sun, you can not go to the sun, we have not been to the sun, and yet we actually know most of the sun is hydrogen and helium. In fact, helium comes from, like the name helium, helios, from the sun, because we actually didn't know what helium was until we actually looked at the sun. It's like, what is this element? It's like, oh, let's call it helium, okay? And today when we get this helium gas, we laugh, right? But that actually comes from that. So you can take this element and you look at the sun, you can figure out what it is made up of. It is made up of hydrogen, helium, and there are a lot of other elements. It has calcium, magnesium, sodium, blah, blah, blah. Now, you can also point your telescope, so it's called a spectroscopy, a fancy word for that. You can point your telescope, look at a star over there, and you look at the spectrum that comes out, and it turns out it has similar elements as the sun. You look at a third star, fourth star, fifth star. So one thing that we find is that our sun and our solar system actually is not made up of anything special. And in fact, the universe is common. Like, it has a lot of these elements that we are made up of, our lives are made up of, and things like that. So even when we talk about ourselves, our biology, we are predominantly made up of carbon, hydrogen, oxygen, nitrogen. John, okay? those are some of the most common elements in the universe. So if we were made up of, say, xenon, like, then we would say, our life is so unique because xenon is not that common, right? Actually, in fact, if you look at the periodic table, the reason why you don't know so many names of those elements that are way up in the periodic table is because those are actually less common. Okay? The top elements are very common. So if we are thinking about life, if we are thinking about extraterrestrials, possibility of extraterrestrials, then the first question is, how common are the elements with which we are made up of? And it's like, those elements are the most abundant elements in the universe. So no problem. Okay. So spectroscopy gave us a way to look at compositions without even going to other places and figuring it out what other stars and planets are made up of. The second key idea was the publication of The Origin of Species. So the idea of evolution. So it connected all the life forms here. And what it said was that, well, if you start with even a simplest of life, the simplest of life, you have the ability through the process of natural selection to get to complex life beings, beings that can think and ask questions of, are there other beings out there? But you can do that simply by a single mechanism or close to a single mechanism of natural selection. So all of biology on Earth is interconnected. We all share the DNA. It's all interconnected. And not just that, there is a mechanism that can go from the simplest of elements, simplest of life forms, to the most complex. And you can do that on Earth. Put these things together, immediately the question comes in. Okay, so the elements with which the life is made up of are really common. And the likelihood that life can start in that context may be high. If life can start and we give it 4.5 billion years, you can lead to complex life forms. If it has happened here on Earth, can it happen on another planet? That's the crux of that. That is what made, these two developments are what made the idea of extraterrestrials, turn it into a scientific idea rather than a philosophical and a theological one. Now, it doesn't mean that the implications are not philosophical and theological. You can still talk about that. But now you have a separate question. We have a way to think about it in scientific terms, and then we can see whether those beings are out there or not. And indeed, actually, and I should mention, just like Thomas Dick, at that time in the mid-19th century, actually, origin of life, which today sometimes people say, oh, how can we explain this and that? And actually, origin of life is one of the tough questions. It hasn't been resolved yet. But in mid-19th century, if you would have said, how did life arise? And people would say, what do you mean? Of course, spontaneous generation. This was the common idea that starting of life actually is the easiest thing. It just appears. Why? Because we have seen it. Where? Well, in meat, people actually say, like, agar aap gosht chhod dein, so there are maggots that appear in it. We actually see the creation of life in it. And so creation of life actually was considered as a given. In fact, as I said, people actually also believe that every other world is inhabited as well. Right? So today when we are thinking about, oh, it's so hard. No, but in mid-19th century, people say, of course there is life out there. Of course, because we actually say it's pretty easy to start up. Okay? And in fact, you take that. So this is, by the way, New York Times. This is from 1907, but this is an astronomer, he was an astronomer, Percival Lowell. He's a fascinating guy. He actually, there is a Lowell Observatory which was later on used to discover Pluto as well. Percival Lowell was not a trained astronomer, but he was a passionate astronomer, and he was very rich, and he built his own telescope, huge telescope. Okay? And he was fixated with Mars. There was a book that came out that said, by an Italian astronomer, Schiaparelli, he said, I think there are canali on Mars. Now, there's a lot of dispute about that. I'm not going to go into details about this. Italian astronomers were writing two different things, one in English and in Italian. So that's all other thing. But Schiaparelli, at least in the English version, meant channels. which are natural. Okay. But when his work got translated, it was translated as canals, which are man-made or intelligence-made or artificial. So Lowell looked at his work and he says, there are canals on Mars. He pointed his telescope and he was like, I can show that. And in fact, these are some of his sketches. He would look at Mars and he would say, there are these canals that people are making. And he had this full theory associated with that, again, go back to this two combinations. He said that Mars, because it's dry, and he believed that Mars was older, and so he believed that there is a civilization out there which is also older. And he believed that if it is older, it's also wiser. And they are dying because they are running out of water. And we know from observations at that time, we knew at that time, that there are polar ice caps on Mars. Just like the Earth, Mars also has polar ice caps. He believed that this civilization, this wise and old civilization, they are digging huge canals to get water from the ice caps and move it to the equatorial regions, and that's what we see. Okay, and he believed that those were 9 feet tall, 9 to 10 feet tall, because Mars has slightly less gravity. So there was no theological component to it, but he had bring in that, okay, so you have evolution, what would happen, and he believed that. So this is New York Times, Mars inhabited, says Professor Lowell. And then here is another one from New York Times. It says, Martians built 2 immense canals in 2 years. Okay. Now, as it turns out, and this is again a cautionary tale, he was seeing too much into the data. And there are no canals on Mars, we know that. Okay. And the reason was because this is what happens when you are really trying to look at things that are at the edge of your technology. So he was looking at it and he was like peering at it and he was like, can I get some more information? And he thought he was seeing canals, but actually it turns out those are dust features. So Mars has huge dust storms and they cover up darker surfaces. But then because of wind, they get swept away. And these features appear, which he thought were canals because he was also drawing. What he's seeing, he's drawing in there. Okay. So it didn't turn out to be there. Now, at this time, again, as I said, everybody thought it's pretty likely that there is life else everywhere. But Alfred Russel Wallace, co-discoverer of natural selection with Charles Darwin, he actually looked at, again, through spectroscopy, he looked at the atmosphere of Mars and he said, it's very thin. He says, only a race of madmen would build canals on the surface of Mars because water would evaporate. So he's also using spectroscopy and he's saying, are you crazy? There is no life on Mars. In fact, it would just evaporate. Now, this is the picture. Mars is dry. Mars is like a desert. Okay. At the same time, late 19th century actually, Louis Pasteur, who we know for pasteurization of milk and things like that, he did the sort of like a fascinating experiment in which I told you about this meat business. Like, if you leave the meat and maggots appear and say, oh, here's the origin of life. So he did a similar thing where he left a flask open where there was a broth in it, and you see, but he insulated it. So there was no air in it. He cleared out the air and he insulated it. Nothing formed in there. Then he did a flask with nothing in it, open with the air, and you had stuff forming in it. And he said, it's not the creation, spontaneous generation of life that we are seeing. Instead, it is something invisible in the air. So he was talking about microbes in the air which we cannot see, but they actually appear. Okay. So this is on the pessimist side. So far people had been really optimistic, but this was on the pessimist side from science. So on the one hand, science can give you the ability, spectroscopy shows, yes, great, there can be life. You had evolution, yes, you can build complex life. But then you had Mars, where the conditions were not good. And you have Louis Pasteur that said, actually, origin of life question is not that easy. And in fact, what we see, spontaneous generation, is not life being created. Okay. So we are going on both sides. So now I'm going to move on to more contemporary words. So this is where the debates are, even right now. If you ask half of astronomers or scientists, is there life in the universe? They say, absolutely. By the way, I'm also included in that. Yeah. If you say, is there intelligent life in the universe? Many say, yes, absolutely. And I'm actually one of those astronomers. Okay, but many also say, with very good reason, no, there is no way. It's actually very hard. Okay. So what do we know? So I'm going to get into the second part and the last part probably to actually say sort of like, what do we know and what can we guess about whether there is life or not. The biggest change that has happened in the last 20 years, if I was giving this talk about 22 years ago, I would be like, I think that I would still say I accept that there's life over there. I really do believe that. But we haven't even discovered any planets outside our solar system. So we are pretty sure there will be planets out there, but we don't know. Okay, that was only in 22 years ago. So I would be starting my graduate school. I would come to T2F even though it wasn't there, and I would come in and say, yeah, there are not even planets out there. But we certainly believe there are planets out there, but we haven't found one yet. But it all changed in 95 when the first planet was, extrasolar planet was discovered. Okay, and it was a very unusual one. It was 51 Pegasus is its name. And one thing, and what was interesting about that, and again, I remember it because I was at a conference when it was announced, and they said there's a big announcement, planet has been discovered, so everybody was trying to figure out what is its orbit, how does it look like, things like that, and people were throwing this number 4, and things like that, so it's like, oh yeah, you're talking about 4-year period, so Earth goes around in 1 year, and it's like, 4 year, but the planet was huge. Was actually bigger than sort of like Jupiter. So it's like, wow, 4-year orbit. I mean, Jupiter takes 11 years. It's an unusual planet. Well, when the announcement came, it turns out it wasn't 4-year orbit. It was a 4-day orbit. Much, 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 much closer to even Mercury. So, so this was actually really a shock because we did not have any way of explaining a Jupiter-sized object so close to its star. Because big-sized planets are only made up of gases, and gases should evaporate if you are so close to its star. But here it was, the first planet we discovered, had a 4-day orbit, and we had beautiful theories of our solar system, formation of our solar system. We explained how Mercury, Venus, Earth, and Mars formed, how Jupiter, Saturn, Uranus, and Neptune formed. We were like, okay, we are just tinkering on our models. And the first planet outside of our solar system, it threw away all of our theories, because it had a very different orbit. By the way, just to give you a comparison, and there are a lot of astronomers here. So Mercury has, I think, 186-day orbit, something like that. So Mercury has a 186-day orbit. 188. There you go. That. Oh, sorry, 88. So okay, 88. You see, that's why I have astronomers here. So 88-day orbit. So here we are talking about a 4-day orbit. Okay. So as of today, actually as of yesterday, I didn't check today. I have to be honest about that. As of today, there are about 3,487 confirmed planets. So in 20 years, we have found this many planets. Okay? 2,611 planetary systems. Basically, close to 600 of these planets are in a solar system, meaning to say they have more than one planet. This is an astounding number. So if you are thinking about, up until 20 years ago, until 1995, the only planets that you figured out was in our own solar system. And they were numbered 9. I still think Pluto is a planet, so yeah, 9. But we are now talking about close to 4,000 planets, and this number is certainly going to increase a lot. Okay, pretty much every star that we have seen closely has a planet. That's what astronomers, and like every star has a planet, pretty much. Okay, so and again, to give you a perspective in terms of strangeness, recently a mission to Pluto. Actually, we thought Pluto would be a boring planet, but it turned out to be something that we had not expected. It had features that nobody had seen elsewhere in the solar system. That is in our own solar system. We go like, oh, what is that? And we are trying to figure out, okay, how can you make nitrogen glaciers, liquid nitrogen glaciers? How can you have mountains that are steely and that, made up of sort of like material that on the inner solar system you cannot form that. So suddenly we have to come up with theories to explain features on Pluto. And that is in our own solar system. Imagine worlds that are out in other parts. Okay? I'm going to come back to it in 1 second. But let me just give you very briefly, how did we discover it? Because again, this goes back to the scientific thinking. So these planets, the 51 Pegasus, the first one that was found, and some of the others ones, have been found with what astronomers call a wobble method. Wobble method is basically it's very hard to find planets because it's hard to see them. They are right next to a really bright star. So the example I like to use is sort of like of a Jugnu. Like, if you're trying to find a Jugnu, because ultimately Jugnus are cool. So in the same way, planets are cool. Nobody cares about bigger things. But Jugnu, hey, look, we want to find that. But if you have a huge flashlight right next to a Jugnu, a floodlight, then Jugnu is there, but you cannot see it because there is a big flashlight right next to it. In the same way, you want to find a planet, but there is a big star right next to it. So you do not see a planet in most cases. But what happens is, what you can see is the movement of the star because of the planet. So our sun is actually moving a little like this. I mean it's moving in around the galaxy as well, but it's also moving in our own solar system because of the push or because of the pull of the planets that are there, in particular Jupiter. So Jupiter is pulling the sun a little bit, sun is pulling all these planets, and all of these are orbiting around what astronomers call or physicists call center of mass. But in our own solar system, all of the center of mass is actually still inside the sun. So our sun does this. And of course, Earth does that, the whole circle and things like that. Now, if you have a big planet, center of mass can be outside of the star. And so the star would start moving like this. If the planet is close by and it's big, like Jupiter, if you bring Jupiter close to the sun, the wobble is going to even more increase. Okay. So now remember, you are not seeing the planet. All you are seeing is this. And you say, wow, that's a Sufi star. No. So anyway, so that's what you find, those planets. So that's exactly how we detected these planets. Just by looking at these motions. And these are tiny, tiny motions if you are trying to look at a star that is many light years away. So this was actually a very hard problem, but we started to see that. But that's how these early planets were discovered. And this is just to, well, I'm going to skip that, but I'm going to skip that. But now many planets, and most of the planets now have been discovered by another method, which is called a transit method or eclipsing method. And what happens is that, again, you are looking at the star. And what happens is, in front of it, a planet goes by. You still cannot see the planet. All you are seeing is the star. But you see a little dip in light. Little dip in light. And so you see the dip of starlight, and you go like, it must have been a planet. And that's how Kepler Space Telescope has been staring at a number of stars, and it is looking at these dips. Actually, it doesn't go that quick because it depends upon, because if there is just one dip, we say it's probably a planet, and we call it a candidate. So we have to wait usually for a second dip to confirm, it was a planet. Okay. Now, Kepler has been out there for I think 9 or 10 years. So far, we have only been able to see planets that are close together, close to the star, because the dip has to go around twice. And so, but now we can actually start seeing smaller planets as well. And indeed, Kepler has been spectacular, and it has found these absolutely amazing worlds. And as I was talking about, that we are talking about some strange worlds out there. So this is just one example. This is Kepler 11 system. So this was the 11th system that was discovered by Kepler. It has, I think, 6 planets. 5 of them are really close to its star, and one of them, this is in comparison, this is the orbit of Mercury, this is the orbit of Venus, and the 5th one is out there. What kind of conditions are going to be in there? You don't know. Here is another, the Tatooine star, from Star Wars fans, they called it, because here is a binary star, 2 stars orbiting each other, yellow star and a red star, and around it there is a planet. So because there was also this one question, can stars be around binary stars where there are 2 stars orbiting each other? And again, originally we as astronomers thought, probably not, because the planet is going to get ejected out of the system. And if that is the case, then the possibility of life gets lower. Why? Because half of the stars in the universe are binaries. So if we would have found that, well, all binary stars are planetless, then you can imagine the likelihood of planets goes down. But actually, it's not stopping it. There are actually planets around binary stars as well. So again, this was called nicknamed Tatooine because it has a yellow and a red star. And so if you remember Luke Skywalker in the first Star Wars, he was looking at the sunset and there were two, one was red and yellow. Not Star Wars fans, okay, all right. So, okay, so, but if we are looking for life, we don't just want to find planets, we want to find planets at the right place, okay? And what that right place is, what is something called habitable zone. Habitable zone is simply a definition which astronomers like to call where water can stay in liquid form. So if you look at our sun and you go further out, if you were close to Mercury or Venus, and if you had water on the surface, it would evaporate because it's too hot. If you go further out to Jupiter, and if you had water on the surface, it would freeze, it's too cold. But if you are here on Earth, water can stay in the liquid form, and in fact, as you can imagine, the way I described it also, it's called the Goldilocks zone, okay, just right, okay. Now, Mars is actually at the edge of the habitable zone. It used to have liquid water ocean on the surface long time back, but now it's no longer there, it got evaporated for other reasons. But Earth is certainly right in the habitable zone. So, if we are trying to find planets, first of all, we would like to find a planet like the Earth. So it's small and solid. Most small planets are solid. So we have to find Earth-sized planets. It's easy to find big planets, but those are mostly made up of gases, like Jupiter, Saturn, Uranus, Neptune. So the key thing was to find small planets which might be rocky. And indeed, here is Kepler. There are now some candidates, Kepler 62f, Kepler 62e. So they are actually in the same part of the same solar system, and 69c and Kepler 22b. So one thing check. Small planets like Earth, people are starting to find it. In fact, now they have found actually one planet that's even smaller than Earth. Are they in the habitable zone? Okay. So I'll actually go over here, and our estimates are, there are now some planets that have been discovered through the Kepler data that are in the habitable zone as well. So you have Earth-like planets in the habitable zone as well. And why we are interested in that? Because all we are saying is, on Earth, you have the raw materials that make life. Again, as I mentioned from spectroscopy, those are common. In fact, even the molecules or some of the simpler elements are actually that are needed for life, like amino acids. They are actually found in comets, just there. There are also experiments done. One of the most famous experiments was the Miller-Urey experiment in the 60s that showed that if you mimic the conditions of early Earth 4 billion years ago, and you try to see what happens, you actually easily create molecules that are the building blocks of life, like amino acids, phosphates, sugars. Those are also found in comets, and comets crashed on the Earth. Okay, so just see that. So in that context, there is plenty of raw material that is available out there, or you can also form raw material here on the planet. All you need are the right conditions, and right conditions are related to being in the habitable zone. Now, do we find planets that are in the habitable zone? Well, we have found some, and we can estimate how many would be in our galaxy based upon that. Kepler itself is just looking at a tiny piece of our own Milky Way galaxy. Our Milky Way galaxy contains 200 billion stars. 200 arab, right? I have to always figure that. 200 arab, okay. Okay, 200 billion stars. Hamara jo Suraj hai is just one of them. Kepler has been looking at, in our own neighborhood, about 1 million stars. That's all it's looking at. Okay, so we can estimate through what it has found, we can generalize it to the rest of the galaxy and figure out how many planets like Earth are out there. And the estimates are, there would be 17 billion Earth-sized planets in the Milky Way galaxy. Our solar system has 9 planets in general, and 1 Earth-like planet, or 2 if you consider Mars. In the Milky Way, there would be 17 billion. And 1 in 5 sun-like stars has a planet, Earth-sized planet, in the habitable zone. That's a lot of planets where life can potentially start. All the conditions are there, and the raw material is there. Okay. So, why do we care? So, this is the last part of the talk. Well, we care about this question because it starts to tell us about who we are. When we have to figure out this question of what is life, it's actually a really hard question. In fact, there is a lot of disagreement about what is the definition, how do you define life? In fact, like, I mean, there was a conference where there were 50 people who work on origins of life, and they were asked this question about what they were supposed to write the definition of life, and there were 50 definitions of life that came out of them. Okay, and so that question is there, like, what is life? And the key aspect is, how does it transfer from chemistry to biology? And what does it mean, transferring from chemistry to biology? It's actually a very hard problem to define. But in order to look for life elsewhere, we have to start defining those questions here. But even more harder, because we are talking about intelligent life in the universe, even more harder is the question, how do we define intelligence? How do we define ourselves? I mean, on Earth, we have many species that have intelligence. Kavve, yahan pe jo hote hain, I mean, I always hated kavve, Karachi mein rehte hue, I mean, but I have a lot of respect for them because they build tools. They can build tools. They are smart. Octopus have been known to open up jars. They can use tools. If you think, okay, the use of tools, well, there are a lot of, especially birds, like a lot of birds use tools. Chimpanzees are other primates other than humans. They all, like, I mean, they show a lot of intelligence. So even on Earth, you have a number of species that have intelligence that we may not be able to communicate, but actually we do communicate with them either. Also, you also have whales and dolphins and so on and so forth. But how do we define it? Well, one way is when we think of aliens and we send them a message. This one is actually a message that was sent to M13, which is a cluster in the constellation of Hercules. It has close to about 100,000 stars or so, a little more than that, 500,000 actually in this cluster. It's called a globular cluster. Okay, and a message was sent, and I forgot how far away is it? M13, anybody know? 26,000 light years away. So in 1974, a message was sent through the telescope in Arecibo. It said, and this was the message. I'll tell you in a second what the message is. But basically it said, hello. And it's going to take 26,000 years to get there, to all these stars. And then over there, there's going to be, if there is intelligent life out there, they detect the signal and they said, hello. It's going to take another 26,000 years to get back to us. And after 52,000 years later, we're going to we found one. Okay. So again, you would say, what's the point of sending this message? Well, the point of sending this message is because it's for us and not for them. Although I have to say, some people did say, send it to far away place so that they don't come and attack us and destroy us. Okay, so we'll talk about that issue in a second as well. But the key thing was, what is this message? Well, I forgot what exactly that was. But you have here the DNA. These are sugars and phosphates. It's all binary, by the way. This whole message is in binary. The total number of bits are, I think, 16, 17, 1617, which I think is a prime number. So they wanted to show like mathematics, like, prime numbers. People will be like, oh, what is prime number? It must be some intelligent species sending us this signal. Here is a human being out there. This is the Earth's population. Here is the solar system. Earth is a little bit up, so this message came from there. This is the Arecibo radio telescope, and so on and so forth. Okay, but the reason is that we had to think, when we are sending this signal, we had to think about how do we talk to people who we share nothing. It's not even that we don't share any culture or sociology. We don't share biology. So if we are trying to talk to them, and we are trying to talk to them, whether they are there or not, we are trying to talk to them, we have to think what would be something that would be universal. Something that completely alien, no pun intended, completely alien, would be say, I can figure it out. But in order to do that, we have to figure out what is absolutely universal, and I'm deliberately saying universal, about ourselves. And so here we have sent in a signal through radio waves, and we have done it in bits, 1010, and we've tried to communicate with them. Another example is this Voyager plate. plaque. Actually, it's in Pioneer spacecraft, also in Voyager spacecraft. And so here is a woman, a man, and here is actually hydrogen atom. And everything here was explained in terms of the sizes of hydrogen atoms and also size of the spacecraft, because if aliens capture spacecraft, it's going out in the outside of the solar system. It's already out of our solar system almost. And we think maybe some alien species are going to capture it. If they do, play this tape. Okay, it has actually sound, it has Urdu in it too. It has a greeting in Urdu. It has a picture of Rawalpindi, a street scene from Rawalpindi. Okay. Is it president's message from here? Oh, US, yeah. Well, it's also not just US president. It actually has a lot of congressmen either also, because they found out that this plaque was going. They said, hey, wait a minute, we funded it. How come our hellos are not there? So it's messages, it's like, and they did that in United Nations. So they got hellos from all these United Nations representatives in all these other languages, and then about like 80 hellos in English, simply because the congressmen that were present were saying, hey, I want to send my hello also into space. But there were a lot of interesting questions. So the question was that whether they should be holding hands or not. Well, that would be friendly. But then the question came in, well, if you do that, then aliens might think that this is a two-headed species, right? So then it was like, okay, so should he raise his hand or not? Like, it's like, well, maybe this is a sign for, hey, we are coming to destroy you, right? Or something more offensive, right? But then they let it go in there, right? Because now we are talking about alien sociology or psychology and things like that. I mean, you cannot think about that. And this is, by the way, a map of neutron stars, which are rotating, called pulsars in our own galaxy. That is a map on how to get to the Earth. We actually gave it to them. So if they are coming, if they capture it, they can come here because we give. And the point was that if there is a civilization out there that is smart enough to capture this Voyager spacecraft, they would have known where are all the neutron stars are in the galaxy. And if they do, they should be able to, then now there is a universal address. You can like, okay, all right, so we are, with respect to these 20 neutron stars, we are here. So we had to figure out what would be the common language. How do we talk to them? And of course, we are assuming here that they understand hydrogen, because hydrogen is the most common element in the universe. Okay, so I am going to sort of like more goes to the conclusion. Ultimately, we are talking about atoms from stars to shared DNA. What we are talking about is you have a universe where you have raw materials that are available. They can form into planets. These planets can potentially have life. Life can have complex processes that can lead to complex beings. Okay, but just a couple of thoughts on what if we do detect aliens. I'm going to go very quickly. We actually kind of know a little bit of what happens if we detect life, extraterrestrial life. In 1994, there was an announcement that came out, 1996, there was an announcement that came out that there is a Martian meteoroid that was found on Earth. Actually, it was in Antarctica that was found over there, that it has fossilized life in it. Okay, this was a big announcement, and again, I remember it. I was in graduate school. We were like all gathered in the conference room. TV was on, and literally we were watching it just like with. It was like, this is big. Everybody was there listening with rapt attention, and then of course immediately we turned to. We had a couple of planetary astronomers, Mars experts, and we were like, okay, what does it mean, and things like that. So the main thing was that this meteoroid was found in Antarctica. There are about 11 meteoroids from Mars that we have found so far. So that means that Mars and Earth actually share rocks. Okay, this particular one is the oldest one, 1 billion years older or a little bit more than that. The thing is that Mars earlier on, a few billion years ago, had a friendly environment, much friendlier to life. So we call it warm and wet Mars. We believe that there was water on Mars, including oceans on Mars, and it was warmer, and so we think it might have and a thicker atmosphere, and so we think it might have had all the conditions there, so it might have had life over there. Not only that, in fact, we think that Mars had better chance of starting life than the Earth earlier on. So if we exchange rocks, it's totally plausible that we all are actually Martians. Okay, it's totally plausible. We don't know. There is a way to test it out. I'll tell you in a second. Okay, so that was the idea. Unfortunately, it turned out, or at least many people think that, they looked at it and they're like, probably it's chemistry, it's not biology. These are actually very tiny features that we are talking about. At that time, it was considered the smallest life we ever know, if this is really life forms. Okay, although now we have found smaller life here on Earth as well. But it turned out not to be the case. Nevertheless, when we thought we had found extraterrestrial life, nothing happened. No riots, no scary things, no sort of upheaval, nothing. Bill Clinton actually gave a press conference about it, and he said it's a really important discovery. And in fact, that press conference was used, interestingly, in the movie Contact. Because Contact was coming in 97, and they were like, oh, let's insert that. He's exactly saying what we think we would say if we had found a signal from extraterrestrial intelligence. Nevertheless, it turned out that it wasn't a Martian life. Okay, but microbial life may not change many things. This is actually a painting of an extrasolar planet behind a star, and you can see some hazy stuff here. Well, as it turns out, now that we are starting to detect planets, we are also starting to image planets, not just indirectly, but actually directly take picture of that. If we start doing it, and there are other telescope plans within the next few years, people will start to look for spectroscopy. They will start to take a spectrum of the atmosphere of the planet. Okay, now, if the atmosphere contains a lot of oxygen, that would imply that there is probably life there. Because on Earth, in our atmosphere, there is oxygen because of life, the blue-green algae. Early life forms here on Earth, for them, oxygen was poisonous. For a long time, oxygen was actually not used. But blue-green algae breathed in carbon dioxide, they exhaled oxygen, and that's what enriched our own atmosphere. And slowly, the life that actually breathed, sort of that couldn't take oxygen, actually got eliminated. And today, our atmosphere is rich in oxygen because of life. We don't know yet of any natural way of enriching oxygen in our atmosphere. So if we find oxygen, we think, so far, that would be a good candidate for life. But I don't think it's the microbial life that matters. The question is, what about intelligent life? And you have two very different views. Carl Sagan believes that aliens would be, if they are advanced, if they are going to contact us, they will give us the Encyclopedia Galactica. They would think that, well, we are here to help you grow up. Okay. Stephen Hawking keeps on saying, don't contact them. They are going to come in and kill us all. Okay. And his idea is that, well, on Earth, whenever there has been an encounter between a highly technologically superior civilization versus a technologically inferior civilization, the technologically inferior civilization has ended up with heavy losses. Okay. Now, we don't know which way is true. Okay. And Carl Sagan's Contact was actually a version of his thing. These are, by the way, both based upon the idea, especially Carl Sagan's one, that cooperation is necessary for human survival. That humans will not survive if they don't cooperate. That's why if there are intelligent beings out there that are technologically advanced, they must have been cooperative. That's the idea. And Stephen Hawking's idea is about the survival of the fittest. He thinks that you can go ahead only if you are ruthless in terms of that. So that's where they are coming in. However, many anthropologists say, don't make analogies. In fact, just thinking about analogies actually is problematic, because you are more likely than not going to make a false analogy. Because here we are talking about people who do not share our own biology. Here there have been many instances where well-meaning people have tried to interact with groups where they thought they knew what they were doing in their favor. It turns out they were completely wrong. So some anthropologists say, actually, don't make assumptions, because we cannot say anything about the biology and about the sociology and culture of civilizations that we don't share any biology. Little pessimistic, but I actually tend to agree on that. I think we have to hold on judgment. Two books I would recommend in this thing: Arthur C. Clarke's Childhoods and actually is a fascinating book. It was written in the 1950s. It is about the basic premises. A big ship comes up and hovers over the earth, and about for 50 years or so, it just hovers over the earth. And then what happens to the society? And so here you have a contact scenario, but Arthur C. Clarke is very smart. He really thought about it. And one interesting thing that I should mention about that is that at the front of the book, there is a disclaimer. And it says on the first of the initial pages, and it says, the views expressed in this book are not necessarily those of the authors, even though he wrote the book. And the reason is because he followed where the story would go. And he himself didn't like the conclusion what he got from that. But he did write the book, and he couldn't get out of that, and he said, this is my book, but I don't agree with my views. That's what he said. Okay, so that in itself makes it really interesting. Okay, the other book is by an anthropologist, Mary Doria Russell. She wrote The Sparrow. This came out in 1990s, 1997, 98. She is an anthropologist, so it's a really interesting book. And I should give you a caveat. It also has a sequel. Don't read the sequel. It's terrible. It actually destroys the first book as well. It's about a mission to nearest star to us, Alpha Centauri. Humans have detected songs coming from they're not sending us signal anything, but we are just hearing songs. So we know that somebody is out there, they are singing songs, we know there is intelligence out there, and then there is a mission before anybody could do anything. The Jesuits, who actually one of the branches within Catholicism, they actually get they have a lot of money, they get a ship, and they sail away to give them the message of God. Okay, but the way they go over there is terrible because she's not a scientist. Okay, so don't be hard on her on that. But once they get over there, the cultural stuff is just phenomenal. It's very complex, and I think it's really good. Most science fiction has terrible culture stuff and terrible romance, but in this one actually you will find, I guess reasonable romance, but certainly good anthropology. Okay, I cannot. Science fiction romances are just the worst. Okay, so we all know that. Okay. Okay, so here is my conclusion. Likelihood of complex intelligent life. I will leave you with some humble expression. We should all go with humility. Here is our planet. All of the biology we know is here. Is there life, intelligent life elsewhere? Well, our sun is just a star. Here are its neighboring stars. We live in a galaxy around here. Okay, this is a schematic of we have about 200 billion stars in our own galaxy. We live about 30,000 light years from the center of the galaxy. Okay, so even if at the center of our own galaxy, we are way out. Okay, and so we say, hi, if there's some important event taking place at the center of the galaxy and they invite us, it's going to take 30,000 years for that invitation to get to us. And then it's going to take another 30,000 years for us to say RSVP it. Okay, and that's at the center of our own galaxy. We actually are in this tiny little spiral arm. We're not even on any of the major spiral arms. We are actually on a tiny broken spiral arm here. Okay, and so again, and the search for our planet so far has been in this area. Okay. And our galaxy is actually part of a group of galaxies called the local group, which contains about 100 galaxies or so. But that local group is actually part of a cluster of galaxies called a local supergroup, which contains, you can talk about sort of about 1,000 galaxies or so. But ultimately what we are talking about is you have in the universe close to about more than 100 billion galaxies. So this is one of the deepest images that humans have taken. Every sort of smudge that you are seeing actually is a galaxy, each containing about 100 billion stars. Okay, so overall we are talking about a universe where you have more than 100 billion galaxies, each one containing close to 100 billion stars. We know just in our own galaxy that we have probably 17 billion Earth-sized planets. So we are talking about a number that we don't have a sort of a trillion or something like that. We are talking about a number in terms of probably a billion trillion and a little bit more. because then you have to add a billion, billion, trillion Earth-sized planets that might be out there. Are we the only one with intelligence out of that? I will leave that question up to you. Thank you very much. Oh, no, 1 second, hold on. And I have to end with two things. There's one ad for, so we do Science Ka Adda, as somebody mentioned in the beginning, like, you know, we have dropped the plus. Well, it's kind of hard to add the plus into this thing, but anyway, the plus is there. So this is a sort of like a short video series. We do that sort of like about, it's a 10-minute each in Urdu about some astronomy thing related to that. So we've done about 13 or 14 episodes. You should actually go out and check on sciencekaadda.com. Our new episode was supposed to have been released today, newest one. It hasn't been finished. I kept on checking it. I think it will be released by a day or two. It's about supernova that was observed by Ibn Sina in 1006. And now today, actually, astronomers are still using interesting data. Now, Ibn Sina had no idea that it was a supernova. But he did look at it. He's like, oh, what's that? And like, you know, and then he looked for things, how it is changing. It was so bright that actually it was visible for 3 weeks and it was visible even during the daytime. And so anyway, so there is an episode. Next one will be about that. And then they also have Hamari Kainat, where Umair Asim is here. He is like, you know, an avid astronomer. He has an observatory in Lahore, and we do it together as a conversation about topics. So those are a little bit more into detail in astronomy, also in Urdu. So that's Hamari Kainat. And I should mention, we have Umair Asim has come from Lahore, from representing the Lahore Astronomical Society, last but not the least. And then you have a whole group of people here that are from Karachi Astronomical Society called KAS. And they were supposed to do observing as well, but we can only look at the rain. But nevertheless, so they are here too. So, I mean, again, there are a lot of people to answer questions about astronomy, and thank you very much for coming. Thank you.
We take questions now. If you show me a show of hands, I'll keep track and then come to you. Go for it, sir.
Okay, so the question is that you have shown that there are many different parameters that you look for in planets, which can tell whether there can be intelligent life or a possibility of life there or not. So one of them is like it should be decent size, like Earth-sized planet. What are the other different parameters that we look for in those planets?
Right. So the question is like, you know, I mean, I just mentioned sort of like Earth-sized planets, but there are other parameters as well. So it's a big question, and so sometime back in 1960, there was a conference. Then when people started to first really systematically think about how many intelligent civilizations may be out there. So Frank Drake, who's an astronomer at Cornell University, he came up with a way to divide up this really big question into small chunks. And he said, well, it depends upon how many stars are in our galaxy. It depends upon how many stars are sun-like, or how many have planets, and then how many are Earth-like, and then how many Earth-like planets, what fraction of them, life will start. And then what fraction of the planets where life started would develop intelligence. And out of those planets with intelligence, what would be the fraction where they would end up with the technology to send or receive signals? Okay. So those were the key parameters they added. Okay. Now, and then there was a last one, which was about lifetime of a civilization. So, but for this purposes, we don't talk about that. Let's eliminate that for a time being. So if you look at this equation, and I'm going from left to right, so yeah, so for you from there, up until 20 years ago, we would have said we actually only know very well about number of stars. Rest of the parameters, we actually really don't know much. And people have filled in numbers, guesses of what those numbers should be. And those are guesses. If you are an optimist person, you find out there are millions of life civilizations out there. But you can also come up with pessimist numbers. And you go like, there really isn't anybody out there. Okay. But most of those numbers before 20 years ago were pure guesses, except for the number of stars. Now actually, because of the number of planets that people have discovered, and where they are found, that left side of the equation is actually relatively well known. And actually the numbers are very high for those things. So the fraction of stars with planets, it's pretty much 1. The number of planets which might be in the habitable zone, it's actually, you can take half, but the likelihood is actually pretty high in there as well. Okay. The next part of the equation, life, intelligence, life, intelligence, civilization, that's a hard question. We don't know. But even if you take a relatively pessimist approach, you still end up, like say for example, you say 1 in a million planets, the one that have an habitable zone would develop life. 1 in a million. And then out of those 1 in a million would develop intelligence. And then out of those 1 in a million would develop technology. You would still end up with some 10 to 100 civilizations, technological civilizations in our galaxy.
Habitable zone.
Right.
If you can tell us a bit about that as well.
Yeah, so habitable zone is basically the place where water can stay in liquid form. Okay, so one is just from the distance. If you are close to the sun, it's too hot, so water would evaporate. If you are too far from the sun, water would freeze and it would be ocean. We think, so again, the reason why we are talking about habitable zone is because one thing that scientists right now agree on about life is that it needs liquid water. And so the search for life in some sense is a search for liquid water. Okay, because now you can say, why do we think that? Well, because life here on Earth requires, we do not know of any life form that does not need liquid water. Now, of course, it's possible of life forms that we don't know, they can be very different, sure. But right now we have to start from some place where we do know what it is. So we have to start someplace like that. And that place is, we need to find liquid water. Now, I should mention, it's not just the distance from the star where it is habitable zone. Moons of giant planets, so like Jupiter's moon Europa, it actually has a liquid water ocean underneath. It's frozen from the outside, but underneath there are volcanoes, underwater volcanoes in Europa. And in fact, there are other moons also. There is Saturn's moon, Titan, not Titan, but Enceladus. Okay, that has actually water geysers. There is water underneath, and those are coming because of the gravity of Saturn and Jupiter that is basically sloshing the moon. Okay, so they have actually liquid water. And in fact, if you're talking about just life, the likelihood right now of a place in our solar system where there can be life, the best place is not Mars. Best place is Europa. And the reason is because we think that life may have originated here on Earth near volcanic vents under the ocean. Those are high temperature conditions, around 100 degrees temperature, and life thrives over there. And in fact, there are very good reasons to think, and again, from the scientific perspective, in fact, there is a very recent paper that has come out, which is a fascinating paper. I can talk about it if you ask me about it, but there are very good reasons now to think that earliest life forms may have been under the ocean, near volcanic vents. Well, the whole reason why there is an underwater ocean in Europa is because there are volcanic vents underneath it. And we also know that there are organic compounds, things that are the raw material for life on Europa. We know that. And we also know, in fact, that the ocean on Europa is, in fact, salt water. It's a salty ocean. So we know all these things actually already. So the likelihood that there will be life is very, very high. Now, but can there be a complex life form where we don't have any complex structure that we can see on the surface of Europa? And it would be hard to live on the surface of Europa. Underwater, well, there's a fascinating debate. Can you develop a complex, intelligent beings that can use tools that do not have a surface? We don't think so. Dolphins have not done that. Like, flippers, it doesn't work. They cannot hold it. The hammer falls off, right? So, but anyway, that's a question. We don't know. There was this movie, The Abyss. It imagined beings under the water. But anyway, so we do not know. But right now, what we know about intelligent life, complex life form here on Earth, underwater, any place where there is no surface probably is not going to lead to tool building complex beings. But life probably yes. So habitable zone actually has also increased because now astronomers consider the zones around these giant planets also as habitable zones. So that's the reason why the numbers have also shot up in the Drake equation. So all of the numbers so far, the ones that we thought would be actually not that high, are actually way higher than we previously thought. So that's the reason why if you do want intelligent civilizations out there to be optimistic, if you are terrified of them, then it's a terrible thing. Like, then you should be terrified. Yeah.
Any others?
So my question is regarding the recent discovery of gravitational waves. So 100 years ago, Einstein predicted that gravitational waves are important, and the Laser Interferometer Gravitational Observatory in the US also detected them. But I can't really wrap my head around the fact that how has this recent discovery of gravitational waves increased the overall potential of astronomy to find new forms of life or to better detect planets and other cosmological phenomena in general.
Okay, so if there are no gravitational astronomers here, gravitational wave astronomers, then I would say it will have no impact on the search for life. And the reason being, gravitational waves are produced by, at least that we can detect, detectable gravitational waves by extremely compact objects. So this was a merger of two black holes, right? Or it can be two neutron stars or two white dwarfs and so on and so forth. But the ones that we can so far detect are the two black holes. We do not think, again, if we are looking for life in places which are similar to ours, we probably would not look at life where there are giant black holes or black holes emerging. And so that's the reason why the gravitational waves would not have any impact on our assessment of life in the universe.
Generally the mapping of the cosmos in the universe, it will help that. Right.
Overall, yes, absolutely. And if I can mention one other thing, the reason why this is so exciting, gravitational waves, is because this is a whole new way of looking at the universe. So let's put it this way. It's like if you had never looked through X-rays or never looked through infrared, and suddenly you have glasses and you suddenly start seeing new things. And so you may see things that we didn't even know existed. So that's going to be exciting to see, use the gravitational wave detector to actually see those. But more likely than not, because they are produced are produced in such high conditions, gravity conditions, that probably won't have any effect on life then. Yes.
Okay. Hello. All right. Don't you think searching for intelligent life is flawed? Like, light travels in a limited speed, and no matter what we do, when we look up in the sky, we look in the past. We're looking in the past. So perhaps we are the only intelligent life in the entire cosmos. So that's why this question is emerging within us, that there might be intelligent life outside, and there's also possibility of, that's what I think, a parallel universe, because we don't know what's beyond a black hole, or when we think of anything else like moon or anything, there's always a distance. Time cannot be ignored, so maybe this entire search for intelligent life is flawed.
But why would time prevent civilizations out there? Why would time have any impact on the existence of them?
I am a political science student, but I have no idea about the entire astronomy thing.
Right.
But this curiosity is within me, right? So I'm like confused.
No, okay, so
Yeah.
I would think the fact that things are far away has no bearing on whether they exist or not. I mean, there's a separate question whether they will visit us or not. That's a separate question, right? But the fact they exist or not, it's independent. Partly, so let me say it another way in terms of time. Life here on Earth has existed for close to about 4 billion years. And species like humans have existed for about 100,000. Right? And our ability to communicate with radio waves and stuff for about 100 years. But even if you take the larger number, 4.5 billion, long time, the problem is the universe is about 10 billion years older than that. So there have been many stars. So when I was giving you the numbers, those are for today. There is sufficient time previously for civilizations to have existed, right? So I don't see, like, even if you see something far away, doesn't mean, like, that they won't exist. It just means that they may not be able to come here. Now, there is this question which is called Fermi's paradox. Fermi was a physicist, and he raised this question, where is everybody? Where is everybody? And sometimes these kind of questions get your name. Every day I try to throw one of those things, hey, how is the weather? But it's not called Salman's paradox. But Fermi has this question, and actually it's a deeper question. His question was, if there are many, 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 many beings out there, okay, then because the galaxy is 10 billion years old, okay, our sun is formed much later, half of the galaxy's time was already done. If there were these civilizations out there that existed, say, 8 billion years ago, right, they should have colonized our whole galaxy. If we, with our technology, if we make the assumption that we will go to Mars, we will go to Europa, we will go to the nearest star, we will go to that. Actually, we can calculate our expansion rate. And even with a conservative expansion rate, we as humans can colonize the whole galaxy in, say, 10 million years or so. We can do that. Right. So, but there are assumptions in there that we would do that. Like, we didn't go back to the moon for a long time. We haven't gone back, like, and so nevertheless, we can actually say. So if that is the case, then if there were civilizations before us, they should have done that. They have plenty of time if they existed. So the question is that why don't we see any structure out there, any evidence out there? So that was Fermi's question. Now, there are many answers to Fermi's paradox. Okay. In fact, there is a book called 50 Answers to Fermi's Paradox. So at least there are 50 answers I know of. But there are many answers, and one of them is like, do they care about us? Maybe, like, they just really, we are on a broken spiral arm way out there. So they go to cool places. They go like, yeah, who's going to go out there? Like, it's a long drive or flight, whatever, like, they take. It's also possible that space flight is hard. That's also possible. And one answer is that we are the only ones. That's a possibility. But again, the last slide for me was like, if you think that in 100 billion galaxies, 100 billion stars in each, close to 20, 30 billion Earth-like planets, we are the only ones, stretches the thing, but maybe. But Fermi's paradox is there. But more likely than that, nobody knows that we are here as well, because our ability to project that we are here only started about 100 years ago. Before that, there was no evidence that there are intelligent beings out here that can actually do things.
There's a question here.
Can we
Change your mind about the question?
Yeah.
There is a black hole also. So there is a possibility of another universe, and definitely this phenomena of black hole we can see on our Earth, like Bermuda Triangle, where everything disappears.
Right.
So there could be the possibility of other universes and like this infinite number of things like that.
Okay, so there are a couple of things. One is, we actually don't need other universes to think whether there is life out there or not, because we have plenty of stars in our own galaxy, right? So the questions of other universes or parallel universes are interesting for a theoretical perspective, but we don't yet have any evidence that there other universes exist. We do not. They may exist, but we do not yet have any evidence for that. And again, we have such staggering number of stars in our own galaxy that we can actually figure that, say, let's limit to our own universe that we know of. We still have, I think, plenty of things to go. And Bermuda Triangle, people have actually looked at in terms of statistics and stuff like that. And in general, there are ways to explain without invoking sort of like, black holes or something like that. And again, because you don't want to have a black hole on the Earth. That would have a lot of other problems with that. So again, so Bermuda Triangle and things like that, that have not really stood up to when people have actually looked at the numbers and stuff like that. The mystery is usually swept away.
सर अभी जो है स्टीवन हॉकिंस जो है वो एक रशियन इन्वेस्टर है, उसके साथ सोलर सेल के बेसिस पे एक स्पेसशिप जो है लेज़र गाइडेड करीब तरीन सितारे पे भेजना चाह रहे हैं, तो उसके बारे में अगर आप कुछ कमेंट कर सकते हैं.
So ये एक it's a really interesting project actually. I don't know आप लोगों को पता है कि नहीं पता कि there are plans के छोटे iPhone जैसे जो हैं वो लेके जो हैं वो they will shoot them through lasers first into space and they will have tiny little solar sails. और idea ये है कि then they will get accelerated through lasers and then they will go. There can be millions of them, million or like whatever number they are thinking about, thousands. And they will go to, they will have tiny little cameras. क्योंकि iPhone के अंदर आपका कैमरा हो सकता है. So they are going to strip everything that is essential, sort of like, you know, they will only keep sort of like the camera, and so these are going to be little tiny, very lightweight things. And they are going to speed them up into space. Laser के साथ they are going to focus them, and that's actually the hardest part. कि you can actually shine laser exactly at the place where the laser is supposed to shine and not fry them, okay, because if you destroy them then it's not going to go anywhere. And the idea is that it's going to go to the nearest star system, Alpha Centauri. Now we don't know whether there is a planet out there or not. There were initial reports that there is a planet, we know, magar now actually it's unclear. But the idea is that lot of these spacecraft, tiny, it's not, they're not spacecrafts, whatever you want to call it, sort of like tiny millions of iPhones. They're going to go there, take pictures, because that's the only way we can take actually really close pictures. And it's going to take, I think, their time frame is, I think, 50% of speed of light. Right, but I think I think in 10 years or so, 2020, no, I think 2030, because they have to develop this technology. जिसके अंदर वो लेज़र जो है it can actually really focus. It's a really hard thing. I think it's totally possible. I think it's a really interesting project. I mean, जब मैंने पहली दफ़ा सुना था I thought कि it was a gimmick, okay, which probably it's also partly the gimmick. मगर it's interesting क्योंकि अगर आपने भेज दिया उधर, right? I mean, it's relatively cheap. You're not there. ये वहाँ पे land नहीं करेंगे. They're just going to go through. Many of them will not make it, but all you need is a few of them to make it, to send you pictures. I mean, they are doing pictures. They may have some spectroscopy also, but I don't know. But pictures certainly. Yeah, they can have instruments, but they have to be very tiny, right? So I just think it's an innovative idea. My guess is that by the time this thing comes along, I mean, we are talking about iPhones right now, but there will be something else. It may be even smaller, or there may be like, you know, some other way of accelerating them. But it's just a good way of thinking about going to other stars. The thing is that we never, before this project, I mean, there have been ideas about how to go to other stars, but they were never really practical ones in the near future. This is the first one that I have seen where there is actually, I go like, interesting. Right? Otherwise, you go like, oh, there will be solar sails, there will be 2-generation ship and things like that. No, but that's not going to happen for another 100 years. Magar, at least. Magar, this thing, I can see it happen. So that's why it actually, it's exciting.
Sir, I've got two quick questions. One is, what is the difference, you have been talking about intelligent life.
Yeah.
So what is a non-intelligent life?
Yeah.
And second question was, I've been associated with merchant navy and sailed for good 10-12 years when there were no satellites and there was no these satellites for navigation. So we used to use astronomy to find the position of a ship using sextant. There were times when it was all overcast, we couldn't see the stars, and for days and days we would sail without positioning, no stars. So question is, do you think there is a scope to invent a mirror which can see stars in the day so that we can shoot them for navigation purpose?
But not during the day, during cloudy days.
During the day.
During days, okay.
Mostly when you are sailing in the sea,
Right.
and at night it's overcast, you can't see the stars. And I'm talking about 50 years ago when there was no satellite navigation. We used to do celestial navigation.
Right.
Planting for many days and days, we would go on a DR position,
Right.
no fixed position.
Right.
And in the daytime there were no clouds, but we could see the stars.
Right.
So we used to talk that maybe someday we can have a sextant, a small mirror or something that.
I don't know, but I mean, you can see stars during the daytime, but it's in radio waves, for example. I mean, you can actually use other wavelengths where the sun is not bright, right? So all you need to do is, but there is a problem, because then you have to, right, but radio waves will not do that. And also, if sun is not bright in radio, the other stars may not be bright. So what you will need to do, and it's a long-term project, but it can happen, is that you have to map the sky in radio waves. Like, you can actually map, and those maps exist. Like, and then use radio telescope for those map stars to find navigation. That might be one way of doing that. Like, but I mean, you have to find where sun is not bright. And those are, and you can also go up in the millimeter waves. And so basically what I'm trying to say is, and this is, by the way, linked with search for life, because when people try to look for optical SETI, so search for extraterrestrial intelligence, people actually look for radio signals. But there is also a way to find optical. And the way to do that is, sun is not very bright in the infrared. So, or red part of the spectrum, red part, it's very bright in yellow. Right? So we can, and humans have the ability right now to build a huge laser that is bright in red. Okay. The idea is, okay, if some alien astronomer is looking at the sun, it would expect a particular type of faintness of light. So yellow is very bright, and then the red should be fainter. What it would find is that yellow is very bright, then it starts fainting, but then there is a peak in red. And you'll be like, why is there this peak in red? And that's because of the laser. Okay. So again, so my point being, you have to find some telescope, which is not at the wavelength of visible. Okay. But in order to do that, you will first have to map in that wavelength to use that for navigation purposes. But I think that is possible.
Sometimes the toilet zone is so narrow,
Right.
like we love serious car because
Right.
it's meant to cheap.
Right, yeah.
But other cars, they get so quickly.
Right.
that they come.
And plus you will have to carry those radio dishes, like, so that would be hard. And your first question.
The intelligent and the non-intelligent.
Oh, that's a very hard question. That's a really hard question. Because as I said, even the question of what is life and non-life.
So may I answer what I'm thinking?
Sure, yes.
I'm thinking like it's me and the octopus. I am intelligent and that is not intelligent.
Why?
Because if somebody was sending signals,
Right.
this octopus is the same octopus that was 100 years ago. But I am not the same human being that was 100 years ago. I have progressed. So I think humans are the only species who have progressed, who have desire, who have developed from point A to point B. Line is still a line. Dog is still a dog.
I would like to ask, I was recently reading this book, and it talks about, like earlier, we would differentiate intelligent, how humans are different from other species, and because we can use tools, and you were talking about how chimpanzees and others, they can use tools as well. So they formulated a theory that what makes us different is because we can think about ourselves, like we can realize about ourselves, and how we can think about other minds as well. So that's what makes us different.
So I think that's so that actually is one of the things. So I'll come back to in 1 second actually, because of the progress. I can actually repeat that question, because I think that's how it is one way of thinking about it, that can we recognize other minds? So other minds question is, I know that you know that I'm thinking, right? So that's 3 orders of intentionality as they call it. And actually humans are capable of 4 orders of intentionality, and even 5. I know that you know that I know that you have a mind, right? Like, so you can go with that. Now, this is important so that you can figure out whether others can think or not. So in many cases, so octopus, for example, probably has a single order of intentionality. Octopus may know that octopus has a mind because it uses it, but it may not know that you also have a mind. But it's unclear. It may have 2 orders. Yeah.
So I have a question I have an answer to your question about how human have progressed and not other.
Yeah.
There's just one difference.
Yeah.
Humans record and actually propagate their knowledge to the next generation. That's the only difference.
Right. So that goes with the culture part, right? That culture. But, and again, so I will actually again make this a little bit complicated, both in this case, intentionality one. So let me do both of those. Intentionality one, the issue is we know that chimpanzees have at least 3 orders of intentionality. And we know that because when they hunt, they actually use deception, right? So they go, so what they try to do is you have calls on one side, okay? And they expect monkeys, if they are hunting, actually they have seen monkeys go that way. And that's where other chimpanzees are sitting to hunt on them. That means what the assumption in there is, what they are doing is that they know that monkeys have a mind in what they are going to do, and so they actually prepare for that. Okay, they don't have one other higher level. Okay, but why stop at 3 or why stop at 4? I mean, why not 3? We can be intelligence as well. So that is one way potentially of intelligence, but why not chimpanzees within that context that comes in? And you were, what was your?
So he said that humans are
culture,
species
right?
that have progressed.
So culture, and again we have to go with the base level. Is there transmission of culture in other animals or not? And it is, because we have seen again amongst primates, especially chimpanzees, that they actually, so there was this famous example in Japan where there was one tribe of chimpanzees which started washing potatoes before eating. And then another tribe right next to them actually started doing the same thing. And now there are actually many examples in the wild where there is this transmission of behavior which is not lateral, but in fact it is which is lateral, actually not vertical, but it is lateral, where they are learning even from non-family, non-kins. Okay, so it's not because otherwise chimpanzees and a lot of other animals actually teach their kids on how to hunt and things like that. I mean,
species are constantly evolving, right? There's a process.
Sure, that is there too.
If I may add on to his first question, and then the discussion that developed over it, in some scientific fashion, we are 4 billion year old life on Earth. And as you said, there have been stars that are older, and there is a possibility that life started and has evolved for more than 4 billion years on some planet somewhere in the universe. And as we saw one of your discussion in which life is evolving, we may assume that some of the intelligence would be of a higher degree than ours, and they would have an understanding of dimensions more than ours, and would have been able to technologically more advanced and be able to communicate with us in forms and in ways more than what we can possibly imagine as of now. So the question is, can we, which is the easier form of communicating with extraterrestrial intelligence, on the receiving end? Why not have some kind of a thinking or a process or a technology to receive a signal of an intelligence which is higher than ours?
Right. I mean, that's a question. So people are looking for radio waves, and so so that actually exactly comes in. What if there is a much better way of communication that we don't know yet, and we keep on looking for radio waves, but actually they are actually communicating and say, I don't know how long will it take for them to actually get to our level. I mean, it's the same way. I mean, if you are communicating right now, you are sending signals, or if there are humans, forget about extraterrestrials. In 19th century, humans are trying to communicate with us, and they're like, okay, well, let's look, for telegraphic signals, we are not hearing from them, or some other forms, it was brought up actually 2 days ago, like smoke signals or something like that. You won't find them because we think radio waves is the best way to communicate, right? So that is absolutely possible, okay? But the reason, and we may be completely wrong about that, we may change our mind about that, but the reason why we think radio waves is a good one is because when we are so say for example, in 100 years, if we are communicating with ourselves or with another civilization that we think, hey, let's look at some inferior technological civilizations, we may actually try to send them a signal through simpler means. But there is a deep flaw in this argument, in the argument that I'm making, that technological progress is linear. Why do we think that 200 years from now, everybody is going to go through technological process in the same way? We don't. So, but you are absolutely right. We don't have any answer to that question. If they are communicating through, there is a better way that is out there, and they are communicating through that, and we are missing that, we are. Absolutely, that's possible. But we cannot do anything about something that we don't know. We can only do something about that we do know. And we do know that radio waves have some advantages. That's the reason why we are looking for. We are also looking for communication amongst civilizations if they are using radio waves. So that's another way of thinking about it. But so far we haven't found any signal.
Sir, is it anything faster than speed of light?
Not so far. Not yet. We don't know. Theoretically there is. Again, theoretically there are ideas. In Interstellar, the movie, like, so there are wormholes. They can travel faster than the speed of light. But again, that goes into a whole different stuff, but you cannot send, as far as we know, we cannot send signals that are faster than the speed of light. But if you watch Star Trek, you can use tachyon beams. Tachyons are theoretical particles that can always travel faster than the speed of light. They can never slow down. Okay, now I loved tachyons when I was before my astronomy, I mean, that's very exciting.
But we have received signals from what are UFOs? We call them psychologically misplaced people. They are the ones who are
Right. I mean, so that's another. I mean, so again, that's a question of whether there is evidence for life or not, and you can actually say there is. I mean, some people do say that. There is, and I teach a course on on this type of stuff, and we spent about a month on alien abductions, and the reason is because those are actually I don't think they are psychologically misplaced. They actually truly believe it, and there are actually good reasons why they believe it, because it's about what is called. It's stepping my not crossing my mind. It's about it happens with when you wake up, but you are sleep paralysis. So it's about sleep paralysis. So we think that that it's fundamentally it is something that and sleep paralysis happen at least in 10% of the people actually repeatedly, and other people actually also experience it. Where when you go to sleep, your body tells you, okay, hey, you are asleep. So, but your brain can run, your critical thinking segment, goes away because it's very expensive to think all the time. And that's the reason why in the dream you can fly and you're not startled, okay? But you don't also want to move your limbs. So if you are running in your dream or walking in your dream, actually you go like, okay, you are sleeping, don't move your limbs. But occasionally what happens is, so when you wake up, usually your mind wakes up and your brain wakes up and then it says, okay, hey, you can move your limbs. But occasionally what happens is that you wake up here, but the signal that you can move your limbs is not there yet. And so that's what's called sleep paralysis, and it's really scary because you seem to be paralyzed by that. Okay, now that's physiological. Now the problem is that, okay, so how do you seek an explanation for that? And there is a template for that, one explanation, cultural template, and cultural templates come from UFO flying or aliens. And that comes in that, well, maybe it was the aliens that were abducting you and you couldn't move, and they were, and so people have actually looked at their narratives of what the abduction narratives are. And actually they are roughly similar. It happens at 4 in the morning, 3:30, 4 in the morning, and they talk about similar things. But what they make meaning of, that's different depending on which culture you are in. And in fact, even if you look at medieval times, there used to be this incubus and incubi. There used to be demons that would sit on the chest. In Muslim countries, you have jinns actually that actually go with that. In people who watch actually Hollywood films, they have actually aliens in there. So actually, this is a fascinating case. But what's interesting is that people who experience this is actually a scary thing. They experience this. We know, as far as we know, they were not really abducted by aliens, but they display PTSD. They actually suffer trauma. And so, and the other interesting thing about this whole experience is, I love this subject, so I'm going a little bit farther. I'm going to come back to the next question. But the other thing is, when you ask them what was the worst thing that happened to you, and they said, and that was one of the things they said, that why would I make it up? And they say, what's the worst thing that happened to them? They said, alien abduction. But they also say that what's the best thing that happened to them was also alien abduction. And partly it's because it gives them meaning. Like, look, out of all these people, who got picked, who got chosen? Me. And then actually their lives truly change. And not just that, nobody believes them. And so they actually have communities of alien abductees. So here is a case where normally if you go and you say, hey, I was abducted by an alien, that's why I'm terrified. People will be like, yeah, right, they laugh at him or her. And the thing is that, but if they find a like-minded community, they say, of course you were abducted. I know, and we all experience that. So you get community as well. So it's actually a fascinating case of community, of meaning in life. You have all of these things together, and so right. So but and surrounded that to this physiological explanation shaped by culture. I think it's just a beautiful example. But yeah.
What effect would the development of nanotechnology have on our search for intelligent life? Say, if we send a payload of raw material to Mars with tiny robots who can, create a rover. So we have about
I mean, I think it would be for
thousands of rovers mapping Mars and
probably for construction purposes. So one of the things that was Arthur C. Clarke, coming back to Arthur C. Clarke, one of his ideas was a space elevator. So the idea, he was like, this is too expensive to shoot up stuff, and it is very expensive. There has to be a cheaper way, right? And he says, well, how about if you actually construct an elevator from down here all the way into space? But it's really hard because you need to have a stable elevator that actually can bend but not break. And up until early 1990s, there was no such thing, no such material that could do that. But now that kind of nanofiber, for example, nanotechnology can potentially do that. So that's, but effect on life, I don't know. But I mean, maybe for construction purposes and things like that. Yeah.
So I saw Interstellar, and I was just wondering, if I'm not wrong, they go searching for a habitable planet, and they choose the one which is near black hole. Yeah. So I was just wondering if it's like really impractical.
Yeah.
And because like the gravitational pull is making the time relative. So why isn't it causing like weird natural phenomena like huge waves and stuff?
Right. Well, first of all, you are exactly right. What you were wondering was something that the director should have wondered. I mean, you are exactly right. I mean, like, okay, my problem was like, okay, so now you have a wormhole. I was like, okay, great, okay. Now, out of the wormhole, they are looking for a habitable planet right next to a supermassive black hole. It's not just a black hole, by the way, it's a supermassive black hole. It's like black holes that exist at the centers of galaxies. It is the last thing you would go over there. In fact, I would have saved a lot of their time and your time by saying, don't go there. This is not the right planet, okay? So you are absolutely right. And again, not to mention that actually there are so many habitable planets, I mean, habitable zone planets that they could have found, okay? The reason why they actually did that was because Christopher Nolan, the director and writer for that, he really wanted to play with time. He wanted that, okay, so 7 hours in one place would end up as 7 hours or 8 hours, whatever, on Earth. He wanted to play with that notion, okay? So Kip Thorne, he's the executive producer of Interstellar. He's the physicist who actually came up with the idea of wormholes, who actually came up with the idea of wormholes for the movie Contact. He actually wrote papers for that. He actually was the original person who was writing Interstellar before Christopher Nolan took it over. But he still remained as an advisor. So Christopher Nolan wanted to make a scientifically accurate film. And he said, but I cannot compromise on this business, So Kip Thorne said, the only place you can put a planet would be basically near a supermassive black hole. So they did that. There is absolutely no logical reason to go there if you are searching for, hey, nice planet for humans. You're absolutely right.
We take, I guess, two more. So there's one here, and if someone else has a question, let me know. What are yours? Okay. Go ahead.
I was listening to Dr. Kaku's physicist, and he was telling that through Hubble telescope, they can actually see traces of dark matter, right, which is invisible to us. So, according to him, extraterrestrial life form may actually be right here. But we just can't see.
Right.
Which is also a concept in Islam.
Yeah. Well, sure. I mean, there can be life here which we don't know what it is. That's always a possibility, right? The question is that what can we actually test? So there can be, and so let me say a few things. So one, there are in science fiction, there are a lot of very interesting ideas that have been explored. There is this science fiction novel called I think it was called Dark Cloud by Fred Hoyle. Hoyle was a very creative astronomer who actually was wrong about a number of things, including the Big Bang and things like that. He coined the word Big Bang, by the way, as to make fun of the idea that there is a start of the universe. But he was brilliant. Okay, he was one of those brilliant scientists, like, who had many wrong ideas and many brilliant ideas at the same time. He just didn't know where to stop, But he thought that, that life was seeded here on Earth, and it's the idea called panspermia, that you have actually life, which is possibility. Right? So he had this novel called, I think, Dark Cloud. I forgot the exact name. Nevertheless, it was the idea that there is a whole cloud that is alive. So you can have life from that, it's possible. Then there is a hard science fiction hard novel. I forgot the name of the author or the name of the book, but they actually imagine really tiny beings living on high density neutron star environment. They actually live inside sort of like the substructure of the neutron star. They have very short lives in milliseconds. They come up and they die. They come up and they die, right? For us. For them, they have a whole life in there. So actually imagine a whole life form. Then it's actually hard science fiction. So actually they go really deep. And the person who wrote those novels actually is a physicist. And he has a whole series of those things, right? So there are all these interesting ideas out there. Now, can there be life here and we don't know? Sure. But that doesn't add anything to our information, because just like we can say, well, there are fairies out here, but there is no way to test them. There may be, but if there is no way to test them, we cannot say anything more other than I truly believe that there are fairies out here, right? So in that same way, can there be dark matter life out here? Well, first of all, I don't know what dark matter life would be, because we don't know what dark matter is made up of. So far, we don't know. There are so far, physicists have been able to constrain some of its properties. We think it's what physicists call WIMPs, weakly interactive massive particles. But we don't know what they are. So until we actually know what dark matter is, we really cannot say anything about life. And then goes back to this question about the definition of life. Are we talking about metabolism? So what kind of metabolism would be made up of dark matter particles? What kind of things that they will be able to replicate in there? Well, but those kind of questions, we cannot say anything about particles that we don't know what they are made up of. So, Higgs boson actually, so it narrows down a little bit about the dark matter range. But Higgs boson is just a particle that exists. We have mass of, every particle has mass because of the Higgs field, what they call. And so yes, Higgs boson is really important, but I don't think it will have any more or less consequences on life. Because there is Higgs boson, that's why we are having conversation. But because there are electrons, we are, yeah.
One quick question.
Yeah.
If the speed of the Earth rotation was double,
Right.
would it mean that teenage would end in 9 years?
What would end in 9 years?
Teenage.
Time would speed up.
18 divided by 2 is 9. Like
Well,
if the
year
rotation
will
was
get
double, would it mean
Right.
that teenage ends at 18, 19? What the...
No, but-
would it also manifest in aging? Speeding the Earth's rotation, would it affect aging in this way?
Is a time derivative of the rotation only?
Right. Well, you will have to go back all the way of how it would impact evolution. So probably, just if you double it, now if you double it, it won't affect that much biologically. But if it had been doubled, say for example, all the way back throughout, we would all have been sort of like evolved in a way to take into account twice the rotation. So in that sense, we would be talking about twice rotation exactly in the same way as we talk about the rotation that we have.
Time is not absolute, it is purely relative. It will not have any effect on our aging, what I mean to say.
But you are talking about aging as if
As a function
this is the way here and we move to another planet where it's moving. That would be the right way to think about it. What if we go to a place where it's rotating twice? Would it impact us? Twice, probably.
People who come back from international space,
Sure.
will not have changed
Negligibly.
Right.
Does the terrestrial movement have a biological effect on us?
Sure. In the sense that, you have tides that impact us, like, a little bit. You can have sort of like cases where there are animals that actually use moonlight, tides, how they come in, they have been shaped based upon that. Other than that, there must be, there are doctors here too, so I can actually put it in there.
There will be a centrifugal force as well, a little bit more. When you rotate something, so little bit gravity.
But those factors are so little. Because our local things are so much more important. So that is one of the arguments when people say astrology works, is that actually it shouldn't, because people say about the moon and about all these things. No, because the doctor that on your birth thing, stuff like that, doctor has far bigger gravity than the moon, for example, like on the baby and so on and so forth. So no. Yes, last question.
Okay, so my question is a bit technical. As we are talking about radio waves are actually electromagnetic radiations. And electromagnetic radiations actually have a huge range from radio waves till you can actually go up to the gamma rays. It's just a different frequency of the photons. So shouldn't we actually go for multiple ranges, not just the longer radio waves?
To search for life?
For search for life.
Oh, absolutely. So ideally, you would like to search all the ranges, right? And so one of the things that people are trying to do is exactly to simultaneously search millions of sort of channels. That's exactly what it is. In fact, people used to do that a lot more. SETI at home. One of the things is it's using your computers to actually analyze data. The problem is you can actually create these huge databases. And in fact, there is a new telescope which is called the Allen Radio Telescope Array. And that will be dedicated to just search for radio signals. There's going to be so much data that's going to be from there, and you can search for it. So yes, the more you search, people should do that, but it's about computation, it's about search. People have looked for optical SETI because that's easier to look for. So far, again, no success. Seth Shostak, who's the head of the SETI Institute, he believes that right now we are getting to the point where we can actually do an exhaustive search on the 50 nearest stars by the year 2025. And he thinks that we are going to find an AT signal by the year 2025, because he said that's when we would know, at least in the nearest 50 stars, definitely, because we would have done actually much more exhaustive search across the spectrum for those stars. I'm actually becoming a little bit more agnostic about this whole thing, and here is a reason why. We haven't found any signals. When 1960, actually, when only 2 channels were used for one star, actually, we were like, oh, we may find something. It didn't. Now their search has been going for 50 years and things like that. And so far, it's not a big search. So the argument against that is well, we've just searched a little bit. Sure. So I don't know whether we will detect something simply from this kind of systematics or not, because again, as the question came up before, we might be looking through a completely different lens, in which we don't know. We might be looking through radio or electromagnetic waves may not be the best way. We don't know, right? So that's a possibility. I just think we may find intelligent civilization, maybe, but it will be because they want us to, which will always be the case, which they want us to find them, but it may not be through the ways that we are looking at. Probably not through radio waves, yeah. So, but I don't know what it would be. Otherwise, we'll be searching in that way, right? Because it's very hard to do.
Thank you so much, Salman. Before I forget, events such as these are made possible by the generosity of Karachiites. There's a donation box right there. And so please give of your monies to it. Thank you so much once again. I'm more convinced than before that Tahir Shah is an alien.
Now that
I think your talk is demystified.
Yeah. Right. No, I'm a big fan, so please, be careful.
As are we all. Thank you so much.
Thank you very much.
Thank you all for being here too.